Alright, we're going to do two sections in this video. We're going to do 8.2, which is dividing monomials, and 8.3, which is scientific notation. And I know you've done scientific notation before, so we're going to spend most of the time on 8.2 here. Alright, so when we divide polynomials, you're going to subtract the exponents. Number 1, b to the 5th over b to the 7th. Makes sense, it's going to be b to the 8th. Subtract the two exponents. Alright, we're going to skip number 2. I'll let you guys try that one on your own. Look at number 3, a squared over a. Alright, if you subtract, you just have a left. B to the 9th over b to the 1st, that's going to be b to the 8th. And c doesn't have anything to join, so it's going to be just c for the final answer. Okay? Alright, take a look at number 5. When you see the coefficients 27 and 3, just remember, those are not exponents, so you're not going to subtract those. You're actually going to divide. 27 divided by 3 is 9. Then you're going to subtract the exponents, so you'll get x squared, and the y's cancel out. Okay, let's try one more just like that. So the 5 on this one is on the bottom. The 5 is just going to stay on the bottom. Nothing you can do to that. X to the 7th over x, subtract them, you get x to the 6th. Y to the 3rd over y, you get y squared. And z squared over z, you get z. And that's your final answer. Alright, the next property on here is that any non-zero number raised to the 0 power is 1. So if you look at 7, 8, and 9 all the way across, every single one of these should have an answer of 1. So when you look in the homework, there's some crazy questions. We have all these a's and b's and c's, x, y, z's, but if it's all raised to the 0 power, the answer is just 1. So don't get tripped up by that. Okay, the last thing on this front page is that negative exponents are the reciprocals of their positive exponents. So look at this example here. 3 to the negative 2nd power is really just 1 over 3 squared. All right, and the reciprocal is true. 1 over x to the negative 1 is the same as x to the positive 1 if you bring it up to the top. Okay, now look at this third example. If you have x to the negative 5 on the top, all you have to do is bring it down to the bottom, make it positive. If you have y to the negative 3 on the bottom, bring it up to the top, make it positive. Okay, now the most common mistake. Look at number 10. A lot of students will say that 6 to the negative 2 equals negative 36 because they think, oh, 6 squared is 36, so to the negative power should be negative 36. That is not true. Make sure when you see that negative exponent, what you really want to do is you want to say 6 to the negative 2 is 1 over 6 squared, which is really 1 over 36. Okay, so when you see a negative exponent, bring it to the bottom. So look at number 11 here. When you see b to the negative 3, I'm going to bring the b's down to the bottom, make them positive. C squared on the top is already positive. I'm going to leave it right where it is. And then d to the negative 5 is on the bottom, so to make it positive, I bring it up to the top. Now I've written everything with positive exponents. All right, you guys try number 12 on your own. All right, 13 and 14 are pretty similar, so let's take a look at number 15. Number 15 is a crazy mess raised to the negative 1 exponent. Now, one way to do this is to simply take that negative 1 and distribute it into everything. So here's what it would look like. It would be 5 to the negative 1. Remember, I should multiply these exponents, so it would be x to the positive 2 now, n to the negative 4, over n to the negative 2, z to the positive 3. That's the first step. Then I can start making everything positive. So if I do that, I'm going to move the 5 down to the bottom. So 5 to the first, down to the bottom. X squared is positive. I'm going to leave it right where it is. If I subtract my two exponents for the n's, think about it. N to the negative 4 minus a negative n to the 2nd. So it's going to be n to the negative 2. Z cubed is already on the bottom, so let's leave it where it is. Now, one more step. We need all positive exponents. So I'm going to move that n to the negative 2 down to the bottom, leaving only an x squared on the top, 5 on the bottom, n squared, z cubed. Now everything is positive. Okay. All right, let's take a look at the word problem. Area of a rectangle is 24 x to the 5th y cubed square units, and the width is 8x cubed y squared. So even if I just start putting together a picture here of a rectangle, and I tell you that the area is 24 x to the 5th y cubed, and the width is 8x cubed y squared. Okay, you do have to remember your formulas. You have to remember the area of a rectangle is base times height, or length times width, however you think about it. So what I'm going to do now is I'm going to insert the area, which is 24 x to the 5th y cubed, equal to, since this one was a length and a width, let's say L times this width that was given. All right, now think of all the algebra that you know. If we want to get L by itself, it means we're going to divide this width over. So what it's going to look like on the left-hand side is that area that was given divided by 8x cubed y squared. Now, let's think of all these properties we just learned. We're going to go ahead and divide 24 over 8. Don't subtract those, you divide those. Then we're going to subtract those exponents for x's and for y's. Now we know our length. Alright, 8.3 is about scientific notation. Now I'm assuming most of you have done scientific notation. So I'm just going to grab one. I'm going to grab this very first one, write in scientific notation, this 30,500,000. Okay, so here's the goal. We want it to be a number with only a 3 point something, a 1 point something, a 5 point something, a number smaller than 10. So for this first one, I would want it to be 3.05 times 10 to the something. Now how I figured out the something is I simply count. So originally the decimal is here. I'm going to count 1, 2, 3, 4, 5, 6, 7 places I moved it to the left. So if I move it to the left, it's going to be a positive 7. If I move it to the right, it would have been a negative 7. So I'll let you try some of those. Again, I'm assuming you've seen this before, so this should not be new. Now here's what might be new to some of you. Take a look at number 3. When I'm multiplying in scientific notation, I'm going to take the 5 times the 2.9, and if I grab my calculator and do that, here's what I get. I get 14.5. Okay. Then with the exponents on the 10, using all the rules I know, I should add those together. I get negative 6. All right, now here's the new part. That's not actually scientific notation. I need it to be 1.45 for scientific notation. Now, if I move the decimal once to the left, I'm going to add 1 to the exponent, so I get negative 5, because negative 6 plus 1 gives me negative 5. So make sure when you do these, you put your final answer in scientific notation. All right, let's try another one. Take number 4. Remember, when I do the division, I'm going to divide the numbers 1.2789 divided by 5.22. When I grab my calculator, I get 0.245. All right, then I subtract my exponents. I get 10 to the 4th. All right, this time, I need to move my decimal to the right one. And when I do that, I'm going to subtract 1 from the exponent instead of adding. So it's going to be 2.45 times 10 to the 3rd, because I'm subtracting 1 from the exponent.